Just confirm if the audio is okay, if you can be able to hear. If the audio is okay now, just confirm. Let me get to know whether the audio is working. So at this given point, we were trying to look at how to determine the turning points whenever you have completing square method. We're going to use completing square method in order to determine the turning point. And then after getting the turning point here, we can be able to sketch the graph. So for you to sketch, you need to know the x-intercept, and also we need to know the y-intercept. And basically y-intercept is value of y when x is equals to 0, which is going to be approximately going to be -3 there. So basically that's what you're going to do. So tomorrow, suppose you are going to have a question to do make use of making use of completing the square. You can be able to use it like that. I know there was a question to do with completing the square in paper 1, so you can be able to have a question like that, maybe or not. So it's not for sure that you will have such a question. Has two roots that are real and distinct, and this is going to mean that b squared minus 4ac has to be greater than 0. That is, now discriminant is greater than 0 whenever you have that. But if you are told that equal roots, you are going to say discriminant is equal to 0, has no solution, discriminant should be less than 0. So in this case, our a is equals to 2, our b is going to be 3k minus 2, and our c is going to be k. Now find the set of possible values for k for which the discriminant for which we have two distinct roots. So we shall say now 3k minus 2 squared minus 4 times a, which is 2, times k, and that is going to be greater than 0. So this is going to be 9k squared minus, this is going to be 12k plus 4, and of course this is going to be minus 8k, should be greater than 0. 9k squared minus 12, and this is going to be 20 here. Minus 20k plus 4 is greater than 0. So that is the inequality you are going to solve in order. So the first thing that you are going to do is to find the principal values of k. The principal values of k is going to be what? So we shall first work out that. So this is going to be 9 minus 20, and then that is 4. So if you find the value of k, k is going to be equals to 2, all k is going to be equals to 9 over 2. Now once you have gotten that, you are going to draw that and represent that on a number line. So this is going to be 9 over 2, and this point here is going to be 2. Now since we are talking of greater than, it means we want values above the line and above the line like that. So the values of k that satisfy this will be k is greater than 2 and k is less than 9 over 2. So those are the range of values of x we're going to do there. In question number 4, we are given coordinates of A, B, C are as follows. Now the line has equation. So we are told that the perpendicular bisector of line AB. So if we are talking of bisector, perpendicular bisector, if we are having a line AB like that, let me just use this as my A and I'll use this as B. So the coordinate for A is negative 4, 3, and the coordinate of B is 6, negative 9. So if we are saying the line is a perpendicular bisector, is a line that runs like that. So which means that these coordinates, or the point where this line is going to cut the x, is going to pass at this point, is going to be the midpoint of AB. So we need to find what is the coordinate of M for this case. So M is going to be equals to, this is going to be minus 4 plus 6 divided by 2, and 3 plus negative 9 divided by 2. So if you can work out this, you're going to get this is going to be 1, and this is going to be minus 3, because 3 plus negative 9 will be minus 6. Then if you are going to divide by 2, you get minus 3. So the coordinate of this point here is 1, negative 3. But you are told the perpendicular bisector of line AB meets L, and our line L is well seated here at point E. So meaning this perpendicular bisector is going to intersect with our line. I'm not saying they are parallel, but I'm just representing this is y is equals to 11x minus 75. So which means that we need to find the equation of perpendicular bisector. We need to find the equation of the perpendicular bisector. Already we have where that perpendicular bisector passes, but we are going to find now the gradient of AB. So gradient of AB, is going to be change in y2 minus y1 over x2 minus x1, and that is going to be 3 minus 9 over minus 4 minus 6, and if you work it out you get negative 12. This is positive 12 divided by negative 10, and that is going to be equals to, this is going to be minus 6 over 5. Then m1 times m2 is equals to negative 1. So meaning that negative 6 over 5 times m2 is negative 1. So which means that m2 is going to translate to what? Positive 5 over 6, which is the gradient of this line that is perpendicular. So we can be able to find the equation of that line that is perpendicular, and that is going to be what? That is going to be equation of the line that is perpendicular is going to be y minus 3 is equals to the gradient, which is 5 over 6 into x minus 1. So this becomes y plus 3 is equals to 5 over 6x minus 5 over 6. So that is, we can say therefore that y is equals to 5 over 6x minus 5 over 6 minus 3. So if you can simplify this, we are going to have minus 5 over 6 minus 3. If you work it out, you get y is equals to 5 over 6x minus 23 over 6. So this is the equation of the perpendicular bisector. This is our perpendicular bisector. So once you have the perpendicular bisector there, once you have the perpendicular bisector, we can now go ahead and solve, because that equation are intersecting, the two lines are intersecting. So we have this line intersecting, so it's intersecting, so we can be able to equate these two parts so that we can be able to get the solution. So we can say 11x minus 75 is equals to 5 over 6x minus 23 over 6. So we can now put the like terms together, so we shall have 11x minus 5 over 6x is equals to 75 minus 23 over 6. So this is going to be 11 minus 5 over 6 gives us 61 over 6 is equals to 75 minus 23 over 6 there. That's going to give us, that's with x, 427, if everything's fine. So divide by 61 over 6, we get our value of x translating to 7. The value of x translates to 7 at this point. Then if we want to find the value of y, we are going to substitute to any of the equations. So we can say, since we have the value of x, we can be able to say therefore y is going to be equals to any of the equation that we have is 11x minus 75, which is going to be 11 times 7 minus 75, and that is going to be 2. So the coordinate E is going to be 7, 2 as the final answer for that particular question. So I believe that is okay up to that point. Let me get to know whether you are following up to that point, if it's okay up to that level, up to the coordinate at the point whereby we are finding the value of E. All right, great. Dev, that is great. I can see your comment there. It's great. That's great. Okay. So find the area of triangle CDE. So let me just minimize this so that we can be able to find that area that is there. Now for us to find the area, let's check here, area of CDE. So the coordinate for C is basically 1510. The coordinate for D is 14, -1. And the coordinate for E is being 7, 2. Now, for us to find the area, we can be able to use shoelace method. And then we're going to say is a half modulus of, we can start with C and say this is 15, 10. Then we write D, which is 14, -1. Then we write E, which is 7, 2. And then you have to cross this by saying 15, 10, the coordinate that you started with. Then we're going to multiply this to that, this to that, this to that. We get the sum. And that is going to be basically a half modulus of. So this is going to be 10 times 14 plus minus 7 times 7 minus 1 times 7. Then plus 2 times 15. Cross that, subtract the product of 15 times minus 1, 14 times 2, 7 times 10, and that is going to translate to 15 times -1 plus 14 times 2 plus 7 times 10. We cross and then modulus. So modulus means whenever we are going, if you are going to get a positive answer, a negative answer, you are going to consider that negative. So this is going to be 14, 140 minus 7 plus 30. That translates to 1/2 modulus 163 minus 15 plus 28 plus 70, that is going to be 83. And if you work it out, this is going to be a half times 163 minus 83, and that is going to translate to 80. And if you work it out, you're going to get it as 40 square units. So that's what you are supposed to do in that particular part, and I believe you've understood up to that point. Just confirm if you got that. Just confirm if you got that. You may be given question to do it small increments. And if you can look at this, you are given y is equal to x squared tan over 2. So which means that you are going to do dy dx. But now this one is a product rule, so meaning we're going to say this is going to be 2x tan x over 2, then plus, now we're going to keep x squared constant, and differentiating tan, we are going to get x squared, so this is going to be 1/2 x squared sec squared x over 2. Find the approximate change in y as x increases from this to that. So meaning that we first need to find what's dy dx when x is equivalent to pi over 3. So we are going to put that in the calculator, and we're going to say this is going to be 2 into pi over 3 and then we do tan pi over 3. So this is going to be pi over 6. Pi over 6 minus 1 over 2 pi over 3 squared, and this is times 1 over cos pi over 6, and then you square that answer. That's how you're gonna put it in the calculator. Check what it can give you. If you put that in the calculator, let's check what it can give us. Just write in the comment section what answer it gives you. If you substitute pi over 3, what does it give you? Just write. And also confirm whether the question is it asking in exact form. If it's not asking in exact form, perfect, we can just proceed. I can see your comment there, Dev. Yeah, so that's one. Yeah, that's true, which is equal to 1.94. And then now we can say dy dx is approximately equals to small increment in y over small increment in x. But the small increment in x is actually h, so which means that this is going to be a small increment in y over h is equals to dy dx. But our dy dx is the value that we have gotten at this particular point. So meaning we are going where we have dy dx, we're going to replace with this part, and then we can now say this is going to be small increment in y is equals to 1.94 h, because if you multiply this, it becomes small increment in y is basically dy over dx times h, all times small increment in x. So if you work it out, your small increment in x is going in y rather is going to be that. And then we have question number 7. Using appropriate quadratic factorization, find the first 3 terms in the binomial expansion of this and in ascending powers of x, and simplify your coefficients. And then part B is asking you to find the independent expansion, the independent expansion of that. So that's what we're going to do in that given part here. Yeah, because if you have such an expression here, what can it factorize to? Because this is the same as, you can be able to write this as 3x plus 2 raised to power 2. But remember, if you were having 5, you can multiply the powers. So we are going to say this is going to be 3x plus 2 raised to power 10. So that is what we are supposed to do. And then we are being told using ascending of x, simplify your coefficient. So find the first three terms in this question. We're supposed to find the first three terms. Yeah, so in order to find the first three terms, we're going to say this is our 3x plus 2 raised to power 10. And that is going to be 3 in ascending power. So I can be able to start by writing 2 plus 3x because we are finding ascending power of x, not descending. So I can be able to interchange this and I write it that way. So the first one will be 2 raised to power 10, then plus the second term, which is going to be 10 combination 1, and then we shall have 2 raised to power 9, 3x raised to power 1. The third term is going to be 10 combination 2, which is going to be times 2 raised to power 8 multiplied by 3x raised to power 2. So that we can now be able to simplify this. We can be able to simplify this. You can be able to use your calculator so that we can be able to get the terms. So this is going to be, this is going to be 10 raised to power 24, then plus this is going to be 13,360. This is 15,360. And the x value is going to be just x. The power of x is going to be 1. And the last one is going to be 103,680 x squared. So that is